Hi everyone, I'm Jeff Malnick. I'm a site reliability engineer at Mesosphere.
And I'm Paul Ambrosini, co-founder of SourceClear.
I used to work at SourceClear. I was a site reliability engineer there for about a year. And we're here to present some of the work that we did on deploying our microservices backend. So how this is going to go down, we're going to talk a little bit about some history and evolution in regards to how we deployed microservices at SourceClear. We're going to talk a little bit about automation principles and some of the principles, some better practices that we came up with regarding how to deploy microservices. And then we're going to do some notes and examples, and then we're going to launch into a demonstration.
All right, so first let's talk about some history, where we started and kind of how we evolved and grew into the microservices that we have now. So in the beginning, there was a coming together of AWS, load balancers, Ansible, SCP, and WAR files, Tomcat, basically what you start with when you first build a service. And obviously it wasn't great. We didn't have really any Puppet or anything running for us that really helped us out. But everyone starts somewhere.
So in the beginning, there was OpsWorks. And if any of you are familiar with OpsWorks, it is basically Amazon's version of Chef. It's a masterless Chef deployment. Paul heroically rolled this out in 2 weeks without having any previous configuration management experience at all. Now, it gave SourceClear a lot of big, massive gains as far as configuration management goes.
Yeah, and it was a huge improvement, had partial CI integration. We took some time to do application and architecture changes, which became a big deal for us. Allowed the teams to deploy separately, and we split up the front and the back end code, and as the title says, massive gains, the productivity for our teams went up significantly. We were deploying, we went from a couple times a week to a couple times an hour if we needed to. Of course, this wasn't perfect. Didn't have dynamic configuration, init files or config files. The CI hooks weren't perfect. We kind of made something work. You need to be in AWS to click a button as well as run something through Jenkins. So it was working, but it wasn't perfect yet. And the one thing I do like to talk about that I learned in OpsWorks is cookbook merging. And cookbook merging is when you have your own Chef cookbook called, so say Tomcat, and you have a AWS cookbook that they built called Tomcat. And what happens is you deploy, and they actually merge all of the code, yours and theirs, into a single one called Tomcat, and then it runs on your box. So if you're trying to copy their code and use it in yours, it'll kind of work only because their code came in. But do you really want their code? It's kind of odd. So it was nice sometimes, and I sat around and helped support with them sometimes, wondering why their code was in my code. So it was OK. And the service health management was somewhat lacking. And then we migrated, which I like to call hiring Jeff, as our first really DevOps ops role person.
So the first thing I did when I got to SourceClear was I looked at the infrastructure they had in place and how they were doing deployments. And it was very much put together very quickly. So the very first thing I did was deployed Puppet. I actually did a Puppet Enterprise deployment for them. And then I also stood up the bare metal provisioning with CloudFormation. If you're not familiar with CloudFormation, it's sort of like Pixie Boot for AWS. We did the entire bare metal, the whole VPC architecture through CloudFormation. And CloudFormation essentially was the starting point for Puppet as well. It set a role file that Factor then basically catted out and classified the nodes with later on. I also set up a continuous integration pipeline that was fully integrated with Puppet. And this pipeline was pretty cool. Basically, at the end of a Jenkins build, Jenkins would post data to our Puppet master, and the Puppet master would rewrite a HIRA configuration file called versions.yaml. And it would update the version, essentially, for any of our services that were running in our infrastructure, and then use MCO to instigate a Puppet run on a role. The system was better, but it had some issues as well. In order to make this whole system work, we had to deploy a lot of use of webhooks around our infrastructure. And the one thing to realize with webhooks, generally speaking, is that they're not asynchronous. So you run into a lot of issues. This right here is a Puppet defined type that I wrote that set up a webhook on our Puppet master to run MCO on a node matching a given role. That was actually kicked off with this service definition. I wrote a provider for HTTP that would then do a post or a get, depending on what kind of webhook it was responding to, at the end of its catalog run. And this is what actually kicked off a run on our internal load balancer to pull down exported resources for the load balancer member resources for HA proxy. And this is kind of our own version of service discovery. We ran into a lot of issues with this, primarily a lot of nodes checking in with our Puppet master with this webhook, and then a lot of sockets waiting in closed wait state down the road. Also, this whole system was still static. So we have our microservices, a source clear, were Spring Boot microservices, and I wrote a Puppet module around them. And this right here is our defined type that would deploy an arbitrary microservice for any Java Spring Boot microservice, essentially. You give it a name, you tell it what deploy stage, i.e. the environment this service is running in, and you give it some port definitions that you have to keep track of yourself. In this case, the deploy stage was also the S3 bucket that it was pulling a jar file from. And you also tell it which internal load balancer it belonged to. In this case, the production internal load balancer. And of course, Puppet is statically scheduling this service to execute on a node somewhere. We don't have any type of any external service discovery or execution framework in place yet.
So a big deal for this is the HA proxy needs to know what service is running, where, and what, in our case, the service and management port. We have health checks on different ports because that's what Spring Boot helps you provide. And it's tough to really point that out with places. And the way we came up with doing it in a non-dynamic fashion is to have 10 ports per box. This was 10 for the service and 10 for the management. And this allowed us to have 10 instances of every service on a box if we wanted to, and you could have as many services as, different types of services as you wanted. Configuration management at this point was used as a hack kind of to force us around the lack of service discovery. And some scaling was achieved. We go up to 10 types of a service per box and many services, but you can't really go beyond that because it only had 10 of a range. And while it does scale, it's not perfect, but we definitely felt like we learned a lot in trying to implement one of our own systems and why this stuff is extremely tough. But let's take a step back for a minute and talk about some different types of principles.
So a standard factory, if you're deploying a data center of any type, either if you're deploying on a cloud platform or if you're deploying in your own DC, whatever it is, you usually have 3 basic steps that you're going to run through to get your layer 7 fully configured. You're going to start with bare metal provisioning, and then you're going to roll into some sort of configuration management tool to actually bootstrap a node. And then you're going to drop into a remote execution framework, and you can also lop in like orchestration utilities in there too, like MCO. Now, at this point, we should probably talk about some of the software principles as well. And we have to start out with the monolith. Everybody in here has had experience with the monolith, I'm sure. As a framework, a monolith is pretty difficult to diagnose what's going on within it because it's a very large code base. If you break a single part of a monolithic architecture, usually the entire application tends to drop down. The code bases are massive, and they grow very quickly, and it's very hard to bring in new engineers on these projects. But for many people, this architecture does work. It just didn't work for us. The monolithic factory tends to have statically scheduled services. You know what port Apache is going to be running on, or Nginx. It's going to be 80 or 443, and you can pre-configure a load balancer with those port definitions right off the bat. You don't have to do any type of service discovery to make that happen.
So let's talk about microservices a little bit now. You want them to be atomic. Keep them as small as possible. You can load them into your head easily. You can get new developers, pushing out code first day very easily. We definitely have this happening a lot when we've been hiring new people. And you can also figure out what's broken quickly. For the most part, you can definitely pinpoint what service is having a problem, but there's a different set of architecture problems where when you bring in people to diagnose something, now they have to understand how all the load balancing works, how all of your services are deployed. Instead of just, it all hits these horizontally scaled boxes, which is much easier than layers of microservices or however you build your system. And wrapping your head around all of it can be rather daunting. Scaling individual pieces is much easier, and you can also add new pieces very easily as well. So the microservices factory, you have dynamic task scheduling, which becomes important as you grow and peak hours happen. And you have some form of service discovery being very much required to not hard code all these port settings like we originally did. In this case, you want to be able to scale correctly, and you want ServiceX to have a set of port assignments. But you probably don't want to hard code those, so you want some form of service discovery to help you figure that out. And you also want ServiceX to have its own configurations for QA or local or prod. We wonderfully can just deploy the same services locally for new developers right away, just spin up all the Docker containers that are in, for example, our QA setup, and they just spin them up locally right when they start, and everything's pretty much set up for them. We wrote a few scripts to do this and a few load balancer things to do it. And you can do development, or you can have all the standard Docker containers just running locally, which has been fantastic for getting new people up to speed. And the big part is you should be able to run service X, Y, or Z on any box and scale it as much as you need to, of course, CPU and memory limiting.
So this brings us to what our talk is actually titled, Vertically Scaled Design Patterns. We discovered that Service X should be able to run as many times as we want on any box. So we wanted to look at the vertical component of this, a single node, and say, okay, if we can deploy Service X n number of times on this box and not have any port conflicts and be able to query some utility to give us all the information about its port settings, its IP address, and everything like that, then we can configure our load balancer with that data on the fly. So at this point, we decided that we were going to find a solution that worked locally, and then moving it out horizontally was going to be child's play. And so that's what brought us to looking at dynamic task schedulers, like specifically Apache Mesos. It's a purpose-built remote execution framework. So essentially, we could use this utility to deploy our Docker containers for us, whereas before we would have to either tell Puppet or another configuration management system to statically deploy this service on a given node matching a role. We could just have a group of resources, and Apache Mesos would take a post of JSON data and deploy as many numbers of those Docker containers as we wanted. Because at the end of the day, a microservice, all it is a streaker. It just wants to be exposed. And you do that by going through the load balancer. What we really needed was a purpose-built system that did this remote execution for us and not try to pigeonhole configuration management into something that wasn't, which was a dynamic task scheduler. We were going to let configuration management do what it does best and let service discovery do what it does best. But this isn't to say that configuration management isn't still necessary. There's a lot of talk that I hear from people these days saying configuration management is becoming a smaller piece of the pie. And in fact, it's more important than ever. We use configuration management for everything from log rotate rules, audit D rules, our IP tables. There's plenty of things outside of layer 7 that need to be configured that you can't do with remote execution frameworks. So our remote execution framework that we chose was Mesos and Marathon. And if you're not familiar with these tools, Apache Mesos essentially makes it so that you can take a grouping of nodes and pool all the resources and execute on them as though they are a single resource. So say you have two nodes, they both have 5 gigs of memory. Mesos makes it so that it looks like 10 gigabytes of memory and then executes services across them. Marathon is a utility that sits on top of Apache Mesos and essentially acts like a REST API into the Apache Mesos infrastructure. So to recap a little bit, now we have this bare metal solution with CloudFormation. It sets a Puppet role, and in this case, what we ended up with in our architecture was setting one of two roles, actually one of three roles, either a Mesos slave, a Mesos master, or a load balancer. For a number of reasons, we didn't do dynamic load balancers on top of Mesos, but I don't want to talk about that here. So the bare metal was setting one of three Puppet roles. And then this is an example of the role that provisioned our Mesos master. So because everything for our layer 7, our app layer, was all inside of Docker containers at this point, our configuration management code was simplified to a great extent. We basically cut down the number of configuration management lines probably down to like 10% of what it was originally, which simplified things for everybody involved in the deployment process. So this is what our Mesos master looks like. We include some basic configurations to get Mesos up and running, configure it as a master, deploy Marathon as a web application, as a Docker container, and then we use a utility called Marathon template to bootstrap an HA proxy instance for us. And Marathon template will then query Marathon down the road and pre-configure that HA proxy configuration with running services for us. So then finally, when we get up to the application layer, we have Mesos purely running this application layer for us, and it's executing all the services for us. And this is great because we don't have, what we ended up having before was sometimes our backend services would die and they wouldn't come back up again until Puppet ran. We solved that in an intermediate solution where we had Docker monitoring the container and we executed the Docker container with Puppet. But when we started to use Mesos and Marathon, then we had a full-time visibility into the state of our services that were running on our backend. And then finally, to actually get the deployment out, to deploy these Docker containers, we used Marathon. And I've got a little snippet of code that I'll give you. You'll see more of this in the demo, but Marathon has a very simple JSON API. And you basically tell the name of your Docker container, and it runs it into Mesos for you. And that brings us to our live demo.
Just drag it over.
OK, so the question is, can people actually read that? Yeah? OK. OK, so let me do pull in a few other windows here. So we have a very simple We have a very simple application that we're going to be demoing here. The application is called Streaker. And it's got three microservices: microbrew, microscope, and micropig. Right now, all the services are not available. If we actually look at how this is deployed, it's a pretty straightforward deployment. We've got an HA proxy that's running the Streaker platform here. And that's actually deployed within the Marathon console, which is right here. So we can see we've got 5 instances of the Streaker platform up, and our HA proxy has discovered those instances. So I'm just going to move this out of the way so I can see what I'm doing. If we look at, let's say we wanted to deploy the microscope service. This is an example JSON that would get posted up to Marathon. And a lot of this is pretty self-explanatory. We've got the name of the Docker image that's going to pull down. We've got a container port, and then we have a host port, and we've set the host port to 0. And if any of you are familiar with Docker, it's essentially setting Docker-P. It's going to allow us to set an ephemeral port between 31 and 61,000. And we'll query Marathon down the road to actually figure out where that is and then update our load balancer with it. Then we've got an ID, and we've got the number of instances that we want, i.e. the number of containers to run within our infrastructure, the CPU limits and memory limits. So this is 16 megabytes. This is a really lightweight Go application. It's taking 0.05 CPUs. In the upgrade strategy, I'll explain in a little bit. So I've got a deploy script here. And all the deploy script is going to do is do a curl post to that Marathon instance that's running up there. So if we run this, and I think I just killed my display. Cool. So we get a return from Marathon. And now if we go back into the Marathon console, that's a little annoying. Window management is, we can see that we've got 10 instances of the microscope service running. And if we go into HA proxy and refresh this page, we're going to have to give this a minute perhaps. Oh, there we go. So HA proxy, queried Marathon, or the Marathon template utility went out and queried Marathon, updated our HA proxy configuration, added it all in here, and now we have the microservice for microscope running in our application.
So Marathon template was something to gem Jeff wrote so we could update our HA proxy constantly. And to explain a little bit about how the Streaker app works, and you see it constantly refreshing, Jeff wrote a little bit of JavaScript that just refreshes the code, the page every 5 seconds or something. And it just goes and gets a URL from each service and then loads it to show you. So it's just a very basic go get data, get it back, and present it to you. Same standard microservice pattern that people use.
Yeah, and if you want to, this is actually all publicly accessible. So if you went to streaker.technoblogic.io/microscope right now, you would see the URI that's currently passing up. So let's go ahead and deploy the other two services. So we'll deploy micropig, and we'll also deploy, whoops. Microbrew, because everybody likes beer. OK, so we'll let this run for a minute. In a sec, we'll see those services come live up here. So one of the really cool things about Marathon is that, and you can see we've got 50 instances of micropig because micropigs are actually really cute if you've never seen them. One of the cool things about Marathon is it allowed us to do cannery upgrades of our backend services in a very easy fashion. If you're not familiar with cannery upgrades, it's basically ensuring that you have a minimum amount of health within your infrastructure. So right now we're running 50 instances of the micropig service. So in a cannery upgrade, we would essentially want to take down that number to say 80% and start moving in the new version of our service and that other 20% that was left over.
Yeah, I've talked to people who are like very scared about upgrade patterns, and they take downtime for an hour to do a database migration or something. What I found working more in the backend code and the way our architecture was structured is that there's actually patterns people have come up with, database migration patterns that you can actually just tie into your code. And this allowed us to just start deploying the new one. And as long as you had like a little bit of backwards compatibility, you can just migrate forward every time. And this works for local QA and prod for everyone. We've been using it. There's always a little gotchas you'll find, but for us, it literally allows us to just git commit and merge a version. Jenkins builds it, pushes it to here, to Marathon, that deploys it, and everything starts upgrading, and we just kind of sit back and grab a beer. And for us, this was literally the most essential part of like not having to touch something after we merge code. We wanted it to be done and finished and drink beer, pretty much.
Exactly. So I'm going to show you what that upgrade, that cannery upgrade looks like. So if we drop down here in the JSON, we've got an upgrade strategy, and it says minimum health capacity 0.8. So that says, I don't want you to drop this infrastructure down below 80% of my running Docker containers right now when I go and do an upgrade. So right now we're running the latest version of micropig. We're going to upgrade this to lot bunnies, which are even cuter than micropigs. And an update is essentially doing a put instead of a post to Marathon. So we'll run that up there. We'll go back into our Marathon console, and we can now see that we've got a deployment in action. and it's actually doing the update to the running Docker containers. And if we drop back into, oh, cool. There we go. OK, so now we have 50 instances of lot bunnies running in our infrastructure. That happened a lot faster than I thought it was going to happen. Usually it takes a few minutes to upgrade all these services, but I probably had the Docker image cached on the slave that it ran on. So by the way, this is actually consuming 2 separate slaves. If we go into the Mesos master console and we look down here, we can see that I have 16 CPUs and 60 gigabytes of memory available. I'm using 2.75 CPUs and 1.4 gigabytes of that available memory. So obviously, I'm not using this as much as I could. I figured that you can only deploy so many of these Docker containers at once and make it, an actual cool demo. But one of the other cool things that Paul and I discovered with Mesos was we got a lot of heat from our director of engineering and our CEO because we had very expensive AWS bills every month. So we were trying to figure out the best ways to maximize the available resources that we had in our infrastructure. And I'm not sure how many of you actually track the usage and the total capacity of your nodes that you're actually running, but some study came out and the actual usage in cloud platforms is egregious. It's something like 5 to 10% because people want to stay very safe. If I decide to go ahead and max this out right now and deploy thousands of Docker containers to my infrastructure, I could over deploy to my infrastructure and I wouldn't break it with Marathon or with Mesos, because Mesos would just say, okay, I've got X number of resources and you want to deploy 110% of my available resources, I'll keep pushing on your cluster until I can actually get to 110%. It's kind of stupid like that, but this is really cool, and it's something you can leverage because if you're using AWS, for example, you've got your backend services on auto-scaling group, and you have your CloudWatch metrics set up correctly, your auto-scaling group will react to that. Mesos trying to push on your cluster, and it will redeploy other slaves for you. And so now you have a fully elastic infrastructure, and that's a really cool thing. And this can be, that could be coming in from you pushing on Mesos, saying, hey, I want to run 110%, or it could be coming from, some other mechanism that you're actually updating this infrastructure.
Yeah, and on top of scaling up, scaling down also becomes very easy when you build something like that, which is all reactionary to the way your system is working.
So that's about it for what we had to show you guys. Want to do some Q&A if anybody has any questions? No? Quiet crowd? Cool.
So I dropped in here a little bit late, so you may have actually even answered this, probably know. But and a lot of this, most of this is very new to me. We've tried and been doing like Dockers using static stuff in Hiera, but I see how this is. Question we're asking, how can you do this more flexible? But the other thing we're trying to do, which we managed to do at Puppet, and maybe we've managed to do it here. How do you load balance? I throw these containers out there, but I need a load balancer up front to manage the network. Did you guys address that at all, or how did you guys do it?
Yeah, so you could do this with Nginx or HA proxy. I chose HA proxy, and here's our HA proxy console. Just because the HA proxy configuration file is very easy to update programmatically. It's broken down into like almost an INI style file. And so we wrote a utility called Marathon Template.
This is actually like one of the problems we had to really address and figure out too, so it's a very good question.
So you can go and check out Marathon Template. It's open source, but basically you put in this, you set up if you're familiar with HA proxy configuration, this YAML configuration file would make a lot of sense to you. Essentially, you build out your configuration as a YAML file for HA proxy. And so this example here is the top half of the file that excludes the back ends, and it would produce this as the actual file. The dynamic part is down here. So right here, you set for the server lines an app name. And that app name is actually corresponding to the Marathon ID of the service. So if we go back and we look at the JSON configuration, we've got an ID down here called micropig-service. And so for this demonstration, my micropig backend is actually just querying Marathon for all instances of the micropig service. And it's kicking back all the IP addresses, basically all of this data. So if I click on micropig, we'll see all the running instances. You can see the actual demo Mesos slave 10.0.0.30 in the port assignment. And then it updates the HA proxy configuration for us. And Marathon template just installs as a cron job and then runs every minute. Just hits Marathon and updates the HA proxy configuration and then does a lightweight reload on HA proxy. You could write a similar utility to do that with Nginx for upstreams. And actually, we kind of wanted to do that just because there seemed to be more support around the Nginx community, but we're pretty satisfied with doing it with HA proxy. That being said, doing this for like a public front end or whatever would require a little bit more care around the security groups or what have you, your IP table rules and stuff, how you set that up. But that's how we came to solve that problem.
Thank you.
Cool. Well, thanks, guys.